All right, the two different types of solutions we have are a 20% solution and a 12% solution. We don't know how much of each, so we're going to call that 20% solution. That one's going to be our X, and our 12% solution, that one's going to be our Y. So now, to find the total, we don't know how much of each, so we're just going to call that X plus Y, and we know that the total amount of liters we need is 15 liters. Then if we look at the percentage, we need at the end 18%. 18% of the total 15 liters. So we know that our total should be that 18% multiplied by the 15 liters to figure out what will the percentage of that total actually be. So we multiply those two together. When we're adding them together, then we have a 20%, which is our X. So we're going to say 20% multiplied by X written as a decimal, and add that with our 12% written as a decimal multiplied by the amount that we have of Y. Both of these equations now show our total. The top one shows the total number of liters, and the bottom one shows the total percentage that we need using multiplication to figure out how much of each will we be adding into our mixture. So now looking at these, I have two equations in standard form. We're probably going to use elimination to help us solve this. So when we do this, we're going to want to rewrite the equations, and it would most likely be easier to multiply the top equation to get a match. I'm going to choose to match my X terms, so I'm going to multiply the top equation by 2/10, that 20%. So if we rewrite it now, we'll have 2/10 X plus 2/10 Y, and that 2/10 multiplied by 15 is going to give us 3. All right, then we can rewrite the equations so they're stacked right on top of each other, and it's going to give us 2/10 X plus 12/10 Y equals still, and that 18/100 multiplied by 15 is 2 7/10. Now that we've simplified that, looking at our problem, we can eliminate one of those terms. If I look at the X terms, they have the same sign in front. Same means we're going to subtract the equations. When I subtract, that cancels out and we have 0x. We can, but we don't need to write it. Then when we subtract 2/10, subtract 12/100, we get 8/100 Y, and 3 minus 2 7/10 gives us 3/10. From there, if we divide by the 8/100 on both sides, Y is going to equal about 3 75/100. So again, Y was representing the number of liters of the 12% solution. So we're going to have 3 75/100 liters of the 12% solution. That's part of our answer. How do we now find the other part? We know that it's X plus Y. So we're going to say X plus, when instead of Y, we have 3 75/100 equals the 15. We can subtract 3 75/100 on both sides. And we're going to have X is equal to then 11 25/100. This time that's for our 20% solution because that is X. It's good to label right at the beginning so we know what each one represents. Now, if we look at it, we were going to an 18%. So we're adding together 20% and 12% solution because in the end we want it to be 18%. 18 is much closer to 20%. So it would make sense that we need more 20% solution than 12% solution to make that the correct mixture. Looking at this next problem, we have a bicycle store costs $2,400 per month to operate. The store pays an average of $60 per bike. The average selling price of each bicycle is $120. How many bicycles must the store sell each month to break even? Ooh, I heard the word break even. Because it says break even, most likely we're going to write it in slope intercept form. Okay. With that being said, we still need two equations. So let's reread the first sentence. The bicycle store costs $2,400 per month to operate. And then the store, in addition to that, pays an average of $60 per bike. So when they purchase them, before they can turn around and sell them, they have $60 per bike and $2,400 per month to operate. So that month, starting off right away, we have $2,400. We're going to use Y to represent the total cost, and we're going to use X to represent the number of bikes. Okay, the total, Y, is going to equal, well, $60 per bike. That happens over and over and over again, so we're going to say 60X. In addition to that, it's a starting cost of $2,400, so we're going to say plus $2,400. Then it says that the average selling price of each bike is $120. Now the store is going to turn around and sell the bikes for $120 each. So the total is going to be equal to $120 multiplied by each bike. Now we have two equations written representing our situation, and we want to know how many bicycles must the store sell each month to break even. We're looking for X. X is our wanted variable. We don't need to know the total, we just want to know X. So looking at this, we can set these equations equal to each other. Instead of saying Y, we can say 120X. So we can write our equation as 120X is equal to 60X plus 2,400. We want the x's to be on the same side, so we can subtract 60x to both sides. From there, we get 60x is equal to 2,400. Well, if I divide by 60 on both sides, 60 cancels out, a 0 cancels out, and 240 divided by 60, x is going to equal 40. X again represented the number of bikes, so we have 40 bikes. 40 bikes are necessary to sell each month for the store to break even. If they want to make money, they'd need to sell more than that. All right, brain break. You can play one round of password with the two names on the board, and then we'll get right back to it. All right, now in this example, we're going to split $1,500 between two savings accounts. Account A pays an annual 5% interest, and account B pays 4% annual interest. If it's annual interest, this sounds like simple interest to me. After 1 year, you've earned a total of $69.50 in interest. So it sounds to me like we have account A, account B, and we're combining two things together. So I'm going to give you a moment for combining two things together. It sounds like we're writing the equations in standard form. See if you can write the equation in standard form and solve this system then.